Okay. Now it's a 10 already. Okay. So yesterday we discussed about IP address. IP address is a logical address. IP address is uniquely identified device in a network. So IP addresses is a uniquely identified device in the network. In the network, to identify a device, it's with a certain address. Logically, uniquely, it is an IP address. And IP address is assigned and configured manually. Means manually can assign an IP address or it will be assigned automatically. Automatically means there is a DHCP server. This DHCP server assign an IP address to our client devices automatically. Like yeah, I have a laptop. To my laptop, I got an IP address automatically from a DHCP server. Okay. Or I have some system. Example, I have a server, some machine is there. I can configure it manually also I can configure. Right. IP address can be changeable, of course. Already configured IP address, we can change it according to our requirements. We can change it manually. We can change it automatically. Also, it can be changed. So right now I'm in office. So obviously, based on my office network, okay, based on my office DHCP server, I got an IP address automatically. So when I go home, as per my home network, in their DHCP server, I will get an IP address automatically. So IP address will be changed automatically based on that network, based on that DHCP server. Or I want to change it manually, also I can able to change. IP address define logical network. So physically, its devices are connected. So you want to make it like that's a physical network. But logical network means it is there is a certain devices with a similar kind of network address kind of stuff. Okay, it's like a logically there are in the same network. Okay, physically all are in the same network, but logically some this group of systems are belongs to logically same network. So these two devices will communicate each other. Other devices cannot communicate because of logical separation. And the two important points, all communications by IP address and every device must have an IP address. And these IP addresses, two parts. One is IPv4 address type, IPv6 version is also there. IPv6 is completely not adapted worldwide. Even small countries like Germany, Japan kind of countries are adapted a complete 100% countrywide IPv6 addressing. But certain countries, some countries are adapted 100%. Some countries still some part we are using IPv6 and some part they are using IPv4. So even the major countries, like not only in India, so in a US, like the countries, big countries, still using IPv4 because their older networking devices know only IPv4 based communication only. But certain private companies, certain countries using IPv6 also. For example, Google use IPv4, IPv6. Okay, Google use IPv4 and IPv6 kind of stuff. Geo using IPv4, IPv6, IPv6 based connectivities. Airtel now the recently Airtel also updated to the IPv6. Okay, so that is like that. And IPv4 system to IPv6 system direct communication is not there. IPv4 configured system with IPv4 you can't communicate it to the IPv6 configured system. Only IPv4 to IPv4, IPv6 to IPv6. If you want to communicate from IPv4 to IPv6, so you need a translator like ISAT app kind of IP 6 to 4 kind of translators are required to communicate between the IPv4 to IPv6. Okay. Yeah, IPv4 is actually 32-bit in a size in a binary format. In IPv6 is 128-bit. IPv4 is 2 to the power of 30 to 4.3 billions of IP addresses. IPv6 is 2 to the power of 128, 4.3. So 3.4 billions of IP addresses. It's around 3.4 into 10 to the power of 38. IPv4 represents in decimal format, whereas IPv6 represents in hexadecimal format. Okay. And again, in the IPv4, okay. So we are already discussed yesterday. Just I'm going to quick revise because this is a very important IPv4 and IPv6 differences. And what is an IP address? Okay, that's why I'm trying to do the some quick revision. So please carefully understand. Okay, IPv4, this is 32-bit IPv4 now. So it is total 32-bit binary. It's divided into 4 octets. It means each octet is getting a 8 bits. That's why it is called a octet. 8 because of 8. Okay, 8 bits, 8 octet. Next, 4 octets. Okay, so we divide into 4 octets, 4 parts. Each part is 8 bits. That's why it's called as a octet. So these 4 octets are separated by a dot, and each octet size is, so it's 8 bit means 2 to the power of 8, 256 means 0 to 255. So 4 octets. The first one is called the first octet, second one is second octet, third octet, and fourth octet. So 4 octets. And also it can be represents WXYZ. Okay, like that. Some people, some textbooks are represented in WXYZ. Good. నీకోసం ఇక్కడికి వచ్చినాను. Okay, sir. So each octet size is ranging from 0 to 255. Means in this octet, there is no number more than 255. Okay, if it is put a 300 any of the octet, like more than 255, it's invalid IP address. Okay, the starting one is 0.0.0, and the final one is 255.255.255. So 0.0.02. The last IP address is 255.255.255. IPv4 address range is 0.0.0 and 255.255.255. Okay. So this is again IPv4 part. Again, IPv4 is divided into 5 classes. So this based on the first octet, of the IPv4. This first octet only it is divided. So if this first octet is between 0 to 127, it's a class A IP address. If first octet is between 128 to 191, it's a class B IP address. If first octet is 192 to 223, it is class C IP address. If first octet is 224 to 239, it's a class D IP address. And first octet is 240 to 255, okay, it's a class C IP address. Okay, so this is the IP address classes. Of course, some IP address of IPv4 we can't assign to any devices. Okay, so that's what are there. We will see it. And already yesterday we discussed now. So take some IP address, see the first octet of the IP address, and verify the range in this one. Find out what is the class of the IP address. Okay, and we are in the differences. In the differences, so there are a lot of differences are there, guys. IPv4, this entire IPv4 range is divided into 5 classes. Again, in these classes, there is a one class is given for a multicasting ranging purpose, and some range is reserved for the R&D. Like a class C, we are not using at all. It is R&D means it is reserved for a future purpose. That's it. Nothing more. Okay. And this class D is a multicast ranging. Is used by certain services like remote installations, remote transmissions, remote configurations, remote sharings. So we use this multicasting. We don't assign it. There are certain protocols, mainly these routing protocols like RAP, IGRP, OSPF. These protocols use a multicast address to advertise their routing information to other routers with the same routing protocols. Boot base is used for a remote installation purpose. It is also like that. Each device uniquely identifies separate unique address, but for same configuration purpose, a separate single multicasting is there. Multicasting means simply a group kind of message. In the group, if you put a message, it means if anyone is putting a message, it is for everyone, right? Like that. 1 second. Yeah. That's okay. Sorry guys, answer called. Okay, I think you guys are having a test. Both version. Some people are having version and some people are having voice and accent. Just 2 minutes. We'll see this one once again and we'll close the session for today. Okay. Just its differences are important. See, this is decimal number, hexadecimal number. Okay. So an IPv6 represents an hexadecimal number. One hexa number is equivalent to 4 binary bits. So 128 means totally 128 binary bits, right? 128 by 4, it is 32 hexa numbers. So one single IPv6 address contains 32 hexa numbers. Okay, this 32 hexa number is divided into 8 blocks. 32 hexa numbers are divided into 8 blocks. So 8 blocks, these 8 blocks are separated by colon. Each block contains 4 hexadecimal numbers. Okay, so each block contains 4 hexa numbers and totally we have 8 blocks. This is the structure of IPv6 address. Okay, and in IPv4 we divide the entire range into the classes. Here it is not like that. We didn't divide an entire IPv6 address into the classes. No classes. But there is a specific ranges are given. There is a specific ranges are given for a different purposes. For example, here it is, you see, this range is in IPv4 is given for a multicasting purpose. Okay. So similarly, here there is a multicasting range is also given like. And communicate in the private means in IPv4, there is a certain private IP address are given. From class A, so 10 series, from class B, 170.16 to 170.31. In class C, 192.168, entire 190.168 series is private IP address only. Okay. But in IPv6, this FC00 colon, this is our private range. So this is completely a private range. Means anybody can take the private IP address, configure in their network. and communicate within that network only. They can't communicate publicly, but within a private, they can communicate. Even you can configure LAN, CAN, MAN kind of stuff within like a private network. You can configure. Okay, it is a routable, but not routable in public wise. Public communication is not there. But if you configure two private networks, you want to make them communicate each other, you can come and make them like it's like a private network. Link local is a special kind of IP address. Link local. It is system generated IP address. Our system itself generating this IP address with a FE80 series. FE80 colon. When you see an IPv6 address, FE80 colon means it's a link local IP address. Non-routable in private, non-routable in public also. It is only private communication within your segmented communication only. Global unicast. When you want to communicate outside of your network, public network, so you have to use this global unicast address. Okay. Anycast. What is anycast? Means only IPv6 enabled devices will do the broadcasting type of communication only. But in IPv4, we have a broadcasting. In IPv6, we have a anycasting. Okay. Loopback or a local host address of IPv4 is 127.0.0.1. In IPv6, it's a colon 1. In IPv4, we have a 0.0.0 is for allow all, deny all, okay? Unknown IP address kind of stuff representation in IPv4. In IPv6, it's just a colon only. Okay, these are the basic differences. Okay, what you will do, so guys, you do your test. Okay, so once in the next session, definitely we'll discuss about in IP address classes. Okay, and their subnet mask and everything we'll discuss. Okay, so here we am going to stop the session because sir told you have a test today. Those who are came just for myself, for my purpose.